Okay, hello everyone. So today we're going to continue on with our Python programming using the Pygame library, and continuing on for the last video where we collected the collectible, but I have these additional exercises here that we're going to work through. So let's get started. So what I have here is a copy of the code from where we left off last time, and actually let me increase the font size just a little bit to make it so that a little easier to see for anyone watching this video. Hopefully that's big enough. So if we run our game now, you can see we can move with our arrow keys, and then if we collect our collectible, a new one is generated somewhere else. Now, there are a few problems here, so we'll start with that for the first exercise. So the random.randrange function calls that we're doing right now don't actually ensure that this entire collectible that's generated is within the boundaries of our screen here. And that is because if you go into the code here, when we're generating the random positions, we're generating some value between 0 and 1 less than the screen width here, or 1 less than the screen height. And because our collectible X and collectible Y positions are the top left corner of where a collectible appears on screen, that means it's possible for a random number to be generated that will place the collectible right down here in the bottom right corner where only like 1 pixel, the top left corner, is shown, basically. And so how can we fix that? That's what we're going to tackle as part of this first exercise here. So to help illustrate what's going on, I'm going to open up Paint here. So let's say this box here is our screen window. And if you'll recall, we have our y-axis going down, and then our y-axis there, and then we have our x-axis going across like this. Oops, X. And then up here in the top left corner we have 0, 0, our origin, X, comma, Y here. So X, comma, Y is this little top corner here of our screen, the topmost pixel. And then going to our code here, when we created our screen up top, we have our screen width and screen height, which are 400 in both cases here. Those form the width of our screen, and since we start at 0, 0, and these are the widths, that means that in terms of like the XY coordinates down here in the bottom right corner, we have screen width in pixels -1, and then screen height in pixels -1. Right, and which if we plug in the actual numbers from our code, we get 400 minus 1 and 400 minus 1, which basically means 399, 399. And that refers to like this little corner right, oops, right down here, the bottom right corner. And so what that also means is that if you were to look at the top right corner here in terms of x, y coordinates, you have screen width in pixels minus 1, and then 0. And then at the bottom down here, in terms of x, y coordinates, you would have 0, and then screen height in pixels minus 1. So that would be this corner right here, and this would be this corner right down here. So when we're generating our collectible, and I'll make this red. Oops. Alright, so when we're generating our collectible, it's going to have XY coordinates somewhere within this screen grid here. And if you'll recall, we have our collectible X and collectible Y coordinates. Those point to the top left corner of our collectible. And so our problem is that when we generate a random number, this could be way down here, and since our collectible has this extra width and height, part of it could be off the screen. And if you'll recall, we have our width and height both the same right now as collectible size in pixels, this constant of 20. So really, the goal is that we need to generate random numbers that will keep the right and bottom coordinates of this collectible within the screen as well. So we can calculate what those coordinates are basically using, math again. So we have collectible X plus collectible size in pixels. So for screen real estate here, let's see, and then collectible Y plus collectible size in pixels. That would be our sort of bottom right corner, and then you could calculate what the top right and bottom ones are as well. So in general, what that means is right now we're generating random numbers from screen width up to screen width and screen height minus 1. And so what we really want to do is change them so that the collectible X that's generated takes into account this width here. And so to do that, I'm going to, I'll do it here. Use a different color here. Let's use blue. So if we want the max collectible X, actually, I can do an equation like this. So we basically have collectible X plus collectible size in pixels, and we want that to basically be less than or equal to screen width in pixels here. And so what that means is that we want our collectible X to be less than or equal to screen width in pixels minus collectible size in pixels. This is just math equations. If you've done any sort of pre-algebra or algebra, you might recognize this kind of concept. If not, you are getting some exposure to it a little bit early. And so, we can do a similar thing to calculate what we want our collectible Y's boundaries to be. Screen height in pixels, and then collectible Y. If we subtract, this from both sides of the equation we have here, we then get screen height in pixels minus collectible size in pixels. So if we can ensure that our random numbers that are generated are less than these values here, then we can ensure that our collectible is going to be completely on screen. And so now all we really need to do is code that up. So I'm going to move this over here to the right side of my screen while I move this over to the left so that you can possibly see it. So basically, I'm going to create some constants to define what the boundaries are. So we want our max collectible X to be equal to the screen width in pixels minus collectible size in pixels right here. Let me adjust that a little bit more. Oops. So because if we do that, then our where's my select tool? So for instance, if I were to sort of copy this, then what we're saying here is we want our max collectible X to basically be this value right here. We are taking the screen width here, and then we're subtracting off this distance right here in order to move back. And then we're doing basically the same thing on the Y. We have our height, and we're subtracting off this distance to get what our new top left corner max should be. So if I do that, then I can change this code here to be max collectible X, and then I can do a similar thing here for max collectible Y. It's going to be the screen height in pixels minus collectible size in pixels. So if we do that, I'm going to need to take this and then put it there. So if we do that, then that should ensure that our collectible won't ever be generated off screen. I'm not sure if I can easily reproduce that here. Because this is randomly generated, but I'll show you kind of what could happen. So let's say if we did set our collectible X equal to the screen width in pixels, and then our collectible Y to the screen height in pixels. And this is technically going to be like -1 because randrange only generates one less than what you give it. So if I run that now, and then I collect the first collectible and generate a new one, you may not be able to see it, but if you look in the bottom right corner, there's a very tiny single red pixel there, and so our collectible's hard to see now, which is bad. But if we change this to max collectible X, and then max collectible Y, and run it now, oops, then ta-da, you can see that it's actually not off screen at all. And I think actually if you look here, you can see one like row and column of black pixels on either side. And that's probably because when we are creating this rectangle here, because it's sort of zero-based coordinates similar to the diagram here, there's sort of an off by 1 error. And so if we really want to make this sort of perfect, then we'd want to add 1 to account for that for our max positions there, if that makes sense. So let's run that and I'll show you what's going on here. Boop. So now you can see there's not any row of black and white pixels there, or black pixels on the bottom and right side of this collectible square. Good, so that's it for the first exercise. And this type of thing that we just did is something done a lot in game programming. So I would recommend you kind of help work to get used to that idea. And then also it's a good reason to sort of make sure you're learning math, because this type of thing comes up a lot. Alright, so that was the first exercise. So the collectibles are currently always the same size. So we're going to change the program so that the sizes, the width and height of the collectibles are randomly generated when you create a new one. Okay. So, and you know what? Actually, to make this, yeah, that's fine. Alright. So, our collectible size is this constant here of 20. So it's always 20 every time we've generated a new collectible. And because I intended it to be constant, that's why I used capital letters everywhere as opposed to lowercase letters, these variables that could change. Now, since we're going to be altering our program so that the collectible size in pixels, and actually let me go ahead and, before we do this, let me save this as a separate file. We'll call this 3.1, and we'll do that random collectible position size fix. And then I'll save this again as a new one for our second exercise here. And this will be random collectible sizes. So anyway, this was something that I intended to be a constant, so to help me when I'm reading my program, I used capital letters to help differentiate it from variables that could change. But we're going to be altering this now. So the collectible size in pixels is going to be variable now. I'm going to let our program change it, so I'm going to make it lowercase. To do that, I'm going to hit Control, Shift, and left arrow key on my keyboard to select that, and then Control C to copy it. And go here, double click on where it used to be referring to our constant, and do Control V to paste, and then do the same thing for the other case here. Now, so if we look at our code here, we'll see that this collectible size in pixels, which is in our game loop here, is getting set to 20 every time. If we want our collectibles to be randomly sized each time, we can't have this happen every time in the loop, and so we'll need to move this out. So I'm going to go select that, right click, cut, backspace to get rid of that blank line, go up to the top, and I'm going to go here, press enter, and then do Control V to set our initial collectible size in pixels to 20. And that'll take it out of our game loop and keep it from getting set to 20 every time we go back into this loop. So now, because we are doing more than just creating a collectible with a new position, I'm going to change this major comment a little bit so it's more accurate to what we want our code to do now, which is just sort of randomly generate a new collectible. There we go. Alright, so we've generated our random position here, but now we also want to generate a random size. So I'm going to take our collectible size in pixels, and we're going to generate a new random value from randrange. So I don't know if you can see this tooltip here on the recording, but I'll go to the official Python documentation for this function. So here, using Python 3 randrange. So anyway, randrange here has two versions. We've been using the version that just has a stopping endpoint, which you can see here we only pass one value to it. But now, we don't want our collectible size to ever be 0 or ever really be 1 or something small like that, because that would be hard to see. And so we're going to have we want to have like a minimum size and a maximum size. To do that, we're going to use the second version right here, which takes a start and a stopping point as well. Just say this is our min value, this is our max value, and go from there, right? Alright, so let's define what we want our min collectible size in pixels to be. What do we want the minimum to be? I'm going to go with 5. I think that probably can be, that's not too small where it'll be hard to read, but it will be fairly small. And then the max, what do I want the max size to be? I'll just pick 30, so it's a little bit bigger than what we've been using as 20, but not super huge. Oops. Alright, so if we want to generate a collectible size in that range, we'll just do min collectible size in pixels. I'm going to press enter here to move my parameters that I'm passing down onto separate lines to make this a little bit more readable, particularly on the screen. So in theory, that should be it for everything here. We're not using the collectible size anywhere other than where we've already changed it, right? So let's run our program and see what goes on. So if I go here, then I get the collectible. Oh, so it looks like I've made an error here. So if you can read this error message, it says collectible size in pixels, which was our constant name, is not defined, and it's talking about line 70. So let's go back there. I forgot to do something. And that's right here. this is an interesting point. So we need to use our collectible size in pixels variable name now with the lowercase letters. But there's a bit of a problem with the way this code is ordered now, because our new collectible is going to have some randomly new size, right? But when we're generating the positions, we're still using the old size. This line of code comes before this line of code, which isn't going to necessarily keep this code working correctly unless the collectible size in pixels always happens to be generated with the same random value, which is not likely to happen. So what we need to do is move this code that updates the size before we calculate the positions. So I'm just going to click and drag with my mouse to select it, and I'll show you how to use the menus here to move code. And then do Edit, Cut, hit backspace to delete some unnecessary lines, press Enter here, and then do Edit, Paste to paste my new code here. Now press Enter to have a blank line for easier readability, and then I need to go back up here and delete this to make the indentation work. So let's try running that again. If I do that, then I should go get my collectible. Oh, that one looks like it's a bit smaller. I get my next one. Oh, that's a bit smaller now. Oh, that's a bit smaller now, or bigger. Oh, different size. So you can see if you look closely, these are a little bit different sizes. I'm going to actually increase the max collectible size here to 50 pixels, just to make it a little more obvious when we see what's going on. Oh, there's a really small one. That one's really close to 5. Alright, yeah, so there's a really big collectible now. So let me get that, and then we'll probably be done. Alright, cool. So that is it for this second exercise. Oh, actually it's not. So right now the width and height are both the same. They're the single size variable. But let's make them different so the widths and heights can be different as well. So if we go back to our program, if we want the width and the height to be different, we're going to need 2 different variables to do that, as opposed to just one. So I'm going to go up here and change this variable to be collectible width in pixels. I'm going to select that, copy it, and then paste it as a new line and change the name here to be collectible height. We'll leave it be 20 and 20, both to start. And then down here, the width comes first, and the height comes second when we're creating a rectangle here by convention. Now here, we'll keep using the same constants for both the width and height. You can create additional ones if you want, but then we'll need to change that to width. And then we'll also need to generate a random height in pixels as well. Do random.randrange. So that generates that. The last thing we need to do is change where we're using the old collectible size variables in these 2 lines. So the X should take into account the width, and the Y should take into account the height. So now let's run this and see what's going on. We have our initial collectible. Oh, ha ha ha. See, there's a really, really skinny one right there. Oh, and there's a wide one, but it's fairly short. So there you go. You're seeing collectibles of a variety of different sizes. So now I think we're done with the second exercise here. All right. The last thing here is we want to basically do a similar thing but for the colors. So I'm going to generate random colors for our collectible. So if you recall, our color values are generally composed of 3 components: red, green, and blue. That's what these are G and B values for. The A is what's known as an alpha value, which is something we're not really worrying about yet. That's a fairly advanced color topic. And you see these numbers are random from 0 to 255. So if I were to go back into Paint here, you can see the random, well, these aren't random, but you can see our red, green, and blue values here. And you can see they go from 0, which basically is all black, to all white, which would be 255, 255, 255. All right, so we need to generate random colors for our collectible. So I'll create a copy of this to save that under a new name for this new exercise. All right, so this is going to be something similar. You'll notice that our color isn't something that's part of this rectangle defining where our collectible is, but it is something we use when we are drawing our collectible here. And so, again, since we're going to be using this and randomly generating new values, I'm going to move this up to the near the top where we're defining all of our collectible stuff. Since I want it to change, I'm going to change the naming style to be lowercase as opposed to uppercase to indicate that we're allowing this to change. And I need to go back and change where we're using the color, which should be right here. So let's just run our program real quick and make sure that doesn't have any obvious crashes. Yeah, so everything's still working. Our collectible's still red. That's fine. All right, so to generate a new color here, we just need to call random.randrange and generate random values for the max color component. Yeah, there we go. All right, so what is this? Well, I mentioned this is going to be 255 because that's the range that we just went through with the colors. Now, since this random.randrange generates one less than what we want, I'm going to just add one in here. I guess technically what we should do up here with the collectible X and collectible Y is alter that too. So yeah, sure. All right, there we go. So now we need to change our collectible color. So we can't do this necessarily and have it work, and I'll show you that right now. So if I do that, well, actually, it does work a little bit because probably of how the color is implemented. So let's see here. If we go to pygame.draw.rect, I'm not entirely sure what's going on here. I guess it's assuming this is like the value for some components or something. But If we want to generate separate red, green, and blue values, I think what we can do is just set the R, G, and B properties of our color separately. So if we do this, that'll set like the red. And then I need something similar here, the green, and then the blue. So this should work now, I think. So we have our initial red collectible. Oh, and now you see we have this sort of light blue one here. And there we go. Yeah, so we're getting a nice variety of colors here. All right, so that's it for the different exercises here. Hope that made sense. If not, you review this video and keep practicing.